When we solve structure elucidation questions, the molecular formula gives us an important clue. It can tell us whether a molecule contains rings, double bonds, triple bonds, or even a benzene ring. This clue is called degree of unsaturation. Degree of unsaturation counts two things: rings and pi bonds. That is the most important idea. It is not just about carbon-carbon double bond. Any pi bond contributes to du. One ring counts as 1 du. Any double bond counts as 1 du because a double bond contains one pi bond. So this includes CC double bond, CO double bond, and CN double bond. Any triple bond counts as 2 degrees of unsaturation because a triple bond contains 2 pi bonds. So a carbon-carbon triple bond and a nitrile group both contribute to 2 du. A benzene ring has a du of 4. It has one ring, which counts as 1 du, and 3 double bonds, which count as 3 more. So 1 plus 3 equals to 4, hence 4 du. If du equals to 0, the molecule has no rings and no pi bonds. So the carbon skeleton is open chain and contains only single bonds. For example, we have aliphatic straight chain or aliphatic branch chain. All these are known as open chain. If du is 1, it could mean one ring or one double bond. The double bond could be CC double bond, CO double bond, CN double bond, or another double bond. So du gives possibilities, not the final answer. Here is an important warning. Cycloalkanes, for example, cyclohexane, they are saturated because they contain only single bonds, but they still have du equals to 1 because they contain one ring. So saturated does not always mean du must be 0. The shortcut formula is du equals carbon minus H over 2 plus 1. Before using it, adjust the number of hydrogens first. Count each halogen as 1 hydrogen. For each nitrogen, subtract 1 hydrogen. Oxygen, ignore. Halogens such as chlorine and bromine behave like hydrogen in this formula because they form one bond just like hydrogen. So C₃H₆Br is treated as C₃H₆ when calculating du. Nitrogen changes the hydrogen count in the opposite way. For each nitrogen, subtract 1 hydrogen before using the shortcut formula, which is du equals to C minus H over 2 plus 1. For example, C₂H₁N is treated as C₂H₆ because 7 minus 1 equals to 6 for the du calculation. Oxygen is ignored in the du calculation. So C₄H₆ and C₄O₂ use the same carbon and hydrogen count when calculating degree of unsaturation. Therefore, O, oxygen, does not change the du calculation. Let's look at some examples. For C₄H₆O₂, oxygen is inert. Du equals to 4 carbon minus 8 hydrogen over 2 plus 1. That gives 4 minus 4 plus 1 equals to 1. So this molecule has one ring or one pi bond. A Du of 1 does not automatically mean carbonyl. It could be a ring or a double bond. But because the formula contains 2 oxygen atoms, a carbonyl containing compound such as ester or carboxylic acid becomes possible. For your information, we are referring to the CO double bond as the carbonyl group. Let's look at the next example. For C₃H₆Br, bromine is counted as 1 extra hydrogen. So we calculate as if the formula is C₃H₆. So the Du equals 3 carbon minus 8 hydrogen over 2 plus 1, which gives 0. A Du of 0 means there is no ring and no pi bond. So C₃H₆Br is an open chain bromoalkane. For the next example, we have C₃H₆. So the Du equals to 6 carbon minus 6 hydrogen over 2 plus 1. That gives 4. A Du of 4 is very important because one possible explanation is a benzene ring. A benzene ring contains 1 ring and 3 double bonds, giving a total Du of 4. But we still need other evidence to confirm the structure. Nevertheless, a Du of 4 often suggests aromatic ring. For the next example, we have C₃H₄. Du equals to 3 carbon minus 4 hydrogen over 2 plus 1. That gives 2. A Du of 2 could mean 1 triple bond, but it could also mean 2 double bonds or 1 ring plus 1 double bond. Du tells us the total number of rings and pi bonds, not the exact structure by itself. Therefore, Du equals to 2 does not always mean triple bond. Degree of unsaturation is useful, but it is only one clue, not the full answer. It tells us how many rings and pi bonds are present, but it does not directly tell us which functional groups is present. We still need NMR, IR, chemical tests, or other evidence to confirm the exact structure of the molecule. In structure elucidation, we usually start with the molecular formula and calculate Du first. Then we use proton MMR to study the hydrogen environments. Together, these clues help us deduce the structure. Therefore, formula first, spectrum second. Quick check. Try this. Find the Du of C₃H₆O. 3, 2, 1. Oxygen is inert. Therefore, our revised molecular formula will be C₃H₆. Therefore, Du equals to 3 carbon minus 6 hydrogen over 2 plus 1 equals to 1. Hence, the answer is B. To summarize, degree of unsaturation counts the number of rings and pi bonds. Use degree of unsaturation equals to carbon minus hydrogen over 2 plus 1. Count halogens as hydrogens. Subtract 1 hydrogen for each nitrogen and ignore oxygen. Any double bond counts as 1. Any triple bond counts as 2. And a benzene ring counts as 4. Du does not solve the structure, but it narrows down the possibilities. In the next video, we will use molecular formula, degree of unsaturation Du, chemical shift, integration, and splitting pattern together to interpret proton NMR step by step. If you want to learn more about A-level chemistry, be sure to subscribe to this channel, and I'll see you in the next one.